Today we've got a really cool subject to talk about. Let's first of all just kind of review what we've learned about slopes. So first of all, we got to find the slopes of each of these lines. So grab a marker. The first one we're going to start with the left point, go to the right point. We have to go down 1, 2, 3, 4, 5. So down 5. That number goes on top because that's the change in y. And then over to the right, 2. So that is our slope, -5/2. This next line, you notice it's a horizontal line. And whenever we have a horizontal line, the change in y does not change. So 3 and 3 are the same. So this has 0 slope. This particular one is going to have a positive slope, and so we jump out of our chair and go up 1, 2, 3, 4, 5. So we went up 5, and then over to the door, so to speak. So over 2, so the slope on this is +5/2. All right, how about this next problem? We're supposed to solve it and graph it on a number line. Well, let's start by getting rid of the parentheses using the distributive property. So 4 times 3x would be 12x. 4 times -2 would be -8. And all of that's less than 2x plus 12. We collect the like terms on the same sides of the inequality symbol. So on the left side we'll have 12x. And 2x comes over and becomes -2x. And all of that is less than 12. And you bring the 8 over to the other side, it becomes +8. So you end up with 10x is less than 20. So pretty straightforward from here. You just divide both sides by 10. And you end up with an inequality of x is less than 2. So on our inequality line here, if this was the location of 2, we'd have an open circle, and we would have an arrow pointing to the left. Just like that. All right, moving on. What is a linear equation? Well, a linear equation is an equation whose graph is a line on a coordinate system. So if you actually graph it, you actually get a sloped line. That's kind of a crazy idea, isn't it? For example, here's a linear equation. Linear equations usually have 2 variables, no exponents other than 1, and they look something like this. Now, if you solve a linear equation for y, which is a very popular and important thing to do, this one would look something like this. And this is a really important form of a linear equation, and we're going to show you why today. And it's going to be basically the premise for what we're studying today. So, if you have an equation, a linear equation that's solved for y, and you have y equals some number times x plus or minus some constant, then each of those terms means something, okay? This is called the slope and y-intercept form of the equation. And so we found out that the m itself is actually the slope of the line that this equation represents. And b is the y-intercept of the line. So what do we mean by that? Let's kind of jump forward here. So first of all, the slope of the line is just how fast or how much it's changing. So in this particular equation, the slope is -3/4. So if I was to write this equation, I would have y equals the slope, which I just found is -3/4 times x, and then the y-intercept, where it's crossing the y-axis, happens to be 5 on this particular problem. Let's try another look here. So the y-intercept, as we mentioned, is the point where the line crosses the y-axis. So this line is buzzing up along like this, and it crosses the y-axis right at the number 4. So that would be the y-intercept of that particular graph. And so knowing that, and if you find the slope, you can actually write the equation. So let's take a look. To put it very simply, the number in front of x, when this is solved for y, is the slope. The number behind x, the one that says plus or minus something, is the y-intercept of the equation. It's that simple. So let's try a couple of practice problems here. As we mentioned, this is the slope is -3, the y-intercept is 5. How about this one? Well, the slope in this case would be 2, because it's the number in front of x. The y-intercept is actually -1 because that's the number behind x, so -1. How about this one? The slope is the number in front of x, which is -1/2. So it's got a negative slope. And the y-intercept, the place where this graph would cross the y-axis, is at +3. Okay, how about this one? Well, the slope is the number in front of x. So we have a 5/4 in front of x. And then over here, there's no number here for the y-intercept. That means there is no y-intercept, so we just put down 0. And that means that this graph would actually cross right through the origin of the graph as it's going across there diagonally. All right, given the slope and y-intercept right, the equation of the line in slope-intercept form. So now that we kind of know what the slope and the y-intercept are, we're actually going to write some of these equations. So if I have a slope of -3 and a y-intercept of 1, my equation will look like this. Y equals -3x plus 1. The next one, y equals the slope x, so 3/4 x, and the y-intercept is -5, so we put subtract 5 right there. Wow, that's kind of easy, isn't it? Let's try this one. Y equals -1/2 x plus the y-intercept, which is 3. This number 4, y equals the slope, which is 7 times x, plus or minus whatever reading there you have for the y-intercept. In this case, it's 0, so we don't even have to write it. Okay, so that's what we're practicing. It sounds like it's kind of straightforward. So you're going to identify the slope and y-intercept today on your ALEKS assignment. Thank you very much.